So that's the test one practice problem for your college, for your intermediate algebra test one. Test one. So let's start with this problem. Question number one. Identify the slope and the y-intercept of the linear equation y equals one fifth x plus 1. Then sketch the graph of this linear equation. So first of all, you know that's a linear equation because the exponents are 1 for all variables, and then the variables only have a coefficient that is constant. So that explains why this is a linear function, linear equation. And also we don't see any other transformation, and that we discuss in class every way that the equation may not be linear. This one is clearly linear. Now, first we need to identify the slope. So you remember y equals mx plus b, where m is the slope, not mx, just m, coefficient of x is the slope, and the y-intercept is 0, comma b. Well, some people say just b, but I don't like to say b because b would be the y value of the y-intercept, but it's not the actual y-intercept because y-intercept would be an ordered pair, which is a point of this coordinate system. All right, so then following this, we can tell that coefficient of x, which is the slope, is 1/5, and the y-intercept is 0, comma 1. This information is enough for us to be able to sketch the graph of this equation. So to do so, we're going to first plot the y-intercept, which is 0, 1. So that means it locates on y equals 1 on the y-axis. And the slope is 1/5. And we remember slope is rise divided by run. Rise up if value is positive, down goes up if value is positive, and rise goes down if value is negative. Run goes right if value is positive, and then run goes left if value is negative. In this case, rise equals 1, and then run equals 5, both positive. So that means we go up 1, and then we go 5 right. And that gives me my ordered pairs, that I can connect if I want. I can do it again. If I go down one, well, I can just connect to avoid all extra work. That's question number one. Question number two, they say write in slope-intercept form. So we're gonna have to solve for y, and then so whenever you have the standard form, and we need the slope-intercept form, we need to solve for y. We need to solve for y. So that said, we will have easily see, we will have the possibility to see the slope and the y-intercept, and then do the same thing we did here to sketch the graph. So negative 3x minus 5y equals negative 20. Let's add 3x. Negative 5y equals 3x minus 20. Then if we divide by 5, negative 5, y equals negative 3/5 x plus 4. Slope is negative 3/5, and then y-intercept is 0.4. So 0.4 negative, we go down 3, 1, 2, 3, and then over 5 to the left. I mean to the right. 1, 2, 3, 4, 5. We connect. Then we extend the line because it goes indefinitely. Okay. Now what's question number 2? Number 3, it says solve the equation. So we're going to distribute, because whenever you see parentheses, you may want to cancel the parentheses. So you have 4x minus 4 plus 2 equals 5x minus 15. We can subtract 4x on both sides. Combine like term first. Combine like terms. 4x minus 2 equals 5x minus 15. We subtract 4x. Negative 2 equals x minus 15. We add 15. We got 13 equals x, or just x equals 13. X equals 13. Next example here is this. We have multiple ways we can start this. If you want to multiply by the LCD, whenever I have fraction, I tend to clear my fractions. So LCD here is 9. If we multiply by 9 everywhere, so that would be x minus 3 equals x. 3x minus 3. So if we add 3, we get x equals 3x. If we subtract x, we get 0 equals 2x. And then if we divide by 2, x equals 0. So we're going to solve this. Multiple ways. If you want to subtract 1 on both sides first, that's fine. Or if you want to multiply by 7, but I'm going to subtract 1 on both sides first, because I remember, I'm sure in the notes, I actually multiplied by 7 first, but since we can do different ways and you get the same answer, so I do it differently from what I have on the actual solutions. So if you subtract 1 on both sides, you get 9x minus 1 plus 1 over 7 minus 6x over 7 equals 0. Then we would multiply by 7. If we multiply by 7, we multiply everything by 7. 7 cancels out. And we distribute the 9. So that's 9x plus 9 minus 6x equals 0. That's 3x plus 9 equals 0. 3x, we subtract 9, equals negative 9. Divide by 3. X equals negative 3. Next, for this one, we still have multiple options, but we want to distribute first. So that's 29 over 18 plus 1 over 2x equals negative 5 over 3x minus 1 over 9. LCD here can be 18. So if I multiply by 18, 18 times 29 over 8 plus 18 times 1/2 x equals 18 times negative 5 over 3x minus 18 times 1 over 9. Okay. Okay, and then, so that cancels this. There's 18 here. So cancels 18. So that's 29. That's 18 times 1. 18 divided by 2, 9. X equals 18 divided by 3 is 6. Negative 6 divided by negative 5 is negative 30x, and then minus 2. 18 divided by 9 is 2. Now we can, let me add 30x on both sides. 30x on both sides. That's 29 plus 39x equals negative 2. That is 5. There's a problem here, because when you distribute this over, that's 5, negative 5x over 3. And this one will be negative 5 over 9. That it's not just 1 over 9. Negative 5. Negative 5. Okay, so this is negative 5 as well. Negative 5. And then, so this will be negative 10. Will be negative 10 because you divide 18 by 9, that's 2, and the 2 you multiply by 5, and the negative sign, that makes it negative 10. Okay, so that's negative 10 here too. So we can subtract 29, that's 39x equals negative 39. Divide by 39, divide by 39, x equals negative 1. So in the next problem, we're going to work on percentage, and we solved problems like this on in class, so that's not going to be so complicated. After eating at a restaurant, your meal came to $23, right? And you decided to give 18% of that amount into the tip, adding into the total cost meal, to the meal cost. If M is your meal cost, write an expression of the total for the meal in terms of M. Okay, in terms of M, that means M is the meal cost plus 18% of M. So M plus 18% of M, that means 0.18 M. And then in this case, it says, what is the amount of the total cost? Amount of the total cost of your meal. Given that M is 23, so that's 23 plus 0.18 times 23. And then if you use your calculator, you're going to have 23 plus 0.18 times 23. That is 27.14. Is your spending. Your current salary is 33,800. If you receive 4% raise last year, what was your salary last year before the raise? So it's like, this is the total that you have, but if X, okay, let X be the amount from last year. That's the amount from last year. So that means X plus 4% of X, which is 4.04, is going to be this amount. That's what they said, right? They said you have this amount that is the raise, that's 4% of last year of what you had last year, that you get added to what you had last year that created this new amount for your salary, for your current salary. So now, since you didn't know what X was, you call it X, then you create that equation, it'll solve for X for you. So that's 1.04x, that equals 33,800. So divide by 1.04, we get X, your salary from last year, that is 33,800 divided by 1.04. So you had a salary of 32,500 last year. Next, we want to solve this equation for X. So in this type of equation, you always want to try to clear the denominators. So I'm going to multiply both sides by this denominator so I can cancel it. So that's 10 minus X times Y equals 8 over 10 minus X times 10 minus X. So 10 minus X gets canceled over there, and distribute your Y, because you're solving for something inside of the parentheses. You would get 10Y minus XY equals 8. Remember, we're solving for X. So we want to keep this one here and then subtract the 10X, 10Y. So that cancels this over here, 0 to 0, and then you get negative XY equals 8 minus 10Y. So if I divide everything by negative X, negative Y, because I'm solving for X, so I can't divide by X. I should divide by whatever multiplies X, so I can remove it. Then I would get X equals, oh my God. Yes, I would get X equals, I'm gonna 8, negative 8 over Y plus 10, or you can say X equals 10 minus 8 over Y. I would prefer the negative term on the back. Here, we are solving this one for, this is too easy. We're solving for B, so I'm going to subtract A on both sides. B equals C minus A. This one we're solving for W.
if we're solving for W, then W is here, W is here. I'm going to distribute, okay? To make my life easier here, I just distribute. S equals 2LW. I'm gonna move this closer, plus WH, 2 WH, and then plus 2LH, right? I'm gonna factor that W out, but let's subtract 2LH on both sides, right? So S minus 2LH equals, I'm gonna factor the W out if you want even the 2, L plus H, right? And then next, we divide both sides by 2L plus H. Then L plus H and 2 cancel. W by itself equals S minus L 2L H over 2L plus H in parentheses. Okay, so next, we're solving this equation for small a. So you know, when you have an equation that has multiple variables, you see how in this one you have a, big A, and small a. You have to consider to write the variables the same way they are given to you. So you can't interchange a, or you can say just a, just a. If they give you large a and capital A and lowercase a, you must consider keeping them just like they are. Now we're solving for lowercase a. So since it's inside of the parentheses and we want to solve for it, we want to try to distribute and then reach the variable that we're solving for. So we're going to distribute over to break the parentheses. So A equals 1/2 AH plus, oh, by the way, another way you can do that is you can multiply both sides by 2 to cancel the fraction. So 2A equals HA plus HB. We distribute 2. So multiply, we do two things. We multiply by 2 and distribute H. Okay, so that's what we did here to get this result. All right, so that takes me to, remember we're solving for this, so I'm going to subtract HB on both sides, or BH. So 2A minus HB equals HA. We divide both sides by H. We get A equals 2A minus HB over H. Or if you divide each term by H, A It doesn't matter. You can give either one. A equals 2A minus 2A over H minus B. Both answers are correct. Next, we are solving this inequality. We already see that this is a strict inequality. That means we're going to use parentheses over the number for the variable. But first, we want to clear the fraction. To clear the fraction here, we would multiply by -4. But you know, when you multiply by -4, the inequality, this inequality changes to this one. We will not forget that. So that will be -4 times 4x plus 3 over -4. And then we switch the inequality to less than or equal -4 times -8. -8. So that would cancel this, and we got 4x plus 3 less than 32. We would subtract 3 on both sides. 4x less than 29. And then we divide by 4. We get x less than 29 over 4. So they ask me to give my solution in all format. First, in notation, in set notation. So that's the set of x corresponding to this such as x less than 29 over 4. On the number line, I'm going to try to see where the 29 over 4 is. 29 divided by 4 is 7.25. So that would be somewhere here, but it's going to be an open. So that's my 29 over 4. And then it's open. It goes all the way to -infinity because it's less than. So that's -infinity. That's the graph. And then the interval notation will be starting from -infinity to 29 over 4, close with a parenthesis because it's not included. Okay. Next example. Here we'll solve this one, but we want to cancel the parentheses first. So we got -13 less than or equal to -9x. We distribute that -9 plus 135. That's 9 times 15. 135. It's a plus, and less than or equal to -6. I'm gonna subtract 135 on both sides. 135 on both sides, on all sides. So we have 135, -135 minus 13. That is -148. less than or equal to negative 9x less than or equal to negative 141. So we divide this by negative 9. We know what's going to happen to the inequalities. So that is 141 over 9 less than or equal to x less than or equal to 148 over 9. Let me see what those values are. 148 divided by 9 is what? 16. So we cannot use this number line. So I'm just gonna cover it and then use my own number line for this problem because the given number line is not fitting the values that we have. So I have this, that's negative infinity, positive infinity, that is 0 right here. Both numbers are positive, so I'm gonna just throw them on the right side. Closer to 0 would be the 141 over 9, which has a closed circle. And then a little farther from 0, we would get 148 over 9, also closed. Also closed. And then the solution will be in between the two values. So that's the green part is my solution, which can be put in interval notation as, in interval notation, a bracket 141 over 9, 148 over 9, close with a bracket. And obviously we could simplify this. Well, actually this only. This one is not it's already a simplified fraction. We could simplify this as if we divide by 3, we would have 141 divided by 3 is 47. So we would have 47 over 3 less than or equal to x less than or equal to 148 over 9. And then we would have, instead of those, we would have, because it's always required when the fraction can be simplified, to simplify it. And then the values would be that. Okay, so just clarify this. Next problem here, we're going to use the values given here so we can sketch this graph, but we can anticipate that this is going to be this is a parabola. It's a parabola, so that means it's going to be a U shape facing up. Well, we can anticipate that this is the answer, but let's actually sketch it. So the values, since we have x equals -3, so y will be -3 squared minus 5, which is 9 minus 5 equals 4. So we got 4 here. For x equals -2, y is -2 squared minus 5 equals 4 minus 5 equals -1. All right, so for x equals -2, y equals -1. Y equals -1. Let's see for x equals -1, y equals -1 squared minus 5. That is 1 minus 5. That is -4. That is -4. And then for x equals -4, -4 here. For x equals 0, we have y equals 0 squared minus 5. That is -5. X equals 1. Y equals 1 squared minus 5, -4. X equals 2. Y equals 2 squared minus 5 equals -1. And then lastly, x equals 3. Y equals 3 squared minus 5 equals 9 minus 5 equals 4. So we have for x equals 1, we have -4. X equals 2, -1, and then 4. So we're going to plot these values in the coordinate system so we can get the curve that we already identified here. We just have to plot it. So we start with -3, -3, 4, -3, 4, -2, -2, -1, -2, -1, -4, -1, -4, -1, oh, -2, -1 here, -1, -4, 0, -5, 1, -4, 2, -1, and then 3, 4. So we see the pattern, we can just connect the dots and then get the actual curve. Okay, so that's the graph of y equals x squared minus 5. And since we already chose the graph, we obviously see this is the graph for it. Here we have this example where we have to find the domain, the range of the equation or the graph, because we don't know if it's a function yet. So that's why we but it looks like a function. We're gonna tell later. So first, domain. Domain is the extent of the graph from left to right. So left, it doesn't go farther from x equals -2. It did not go farther on the right from x equals +3. But because we see there's a closed circle at -2, then we start the domain on the left, from left at -2 with a bracket because we have a closed circle. And then we go all the way no farther than 3 because that's where it stops. And it's 3, but at 3, there is an open circle. That means 3 is not included. So I put 3 with a parenthesis. So that is for the domain. Now, the range is the extension of the y. We see that it did not go lower than y equals -5 with an open circle. So parenthesis -5. And it did not go higher than 4. But now you don't see a circle. If you don't see a circle, it touches the line, then it's a closed circle. If you don't see an open circle, you need to assume that it is a closed circle and it touches the line y equals 4. So that means 4, I'm going to close it with a bracket. So that these are the domain and the range of the graph. Now they say the relation, let's replace this by relation instead of function, because the function is when you know it's a function. A function is a relationship, it's a relation, but not all relation are functions. So that's why you need to make sure you make the difference. Here, is it this relation? Is it a function or not a function? Well, how do we know? We know that it's a function when all the vertical lines possible intersect this only once. Well, I'm drawing a few, but even if you draw an infinite number of vertical lines, they will always intersect this once. So that makes it a function. Yes, it's a function because all the vertical lines will intersect this graph only once. Now, let's look at this other example. Same scenario, but you need to assume that this goes forever. And you can see how it continues to go down as you go, it continue. It continues to go left, but also down, also up. You need to keep this into consideration as you looking for the information. So we have to make sure we also identify this as a relation, not an actual function. So the domain is the extension of x over the x-axis. So we can see it goes forever to the left. So that's -infinity. It didn't go farther from 0. And it touches this. So that's a 0 with a bracket. And how about the domain? The domain what I see is that it covers the entire, because it continues to goes down. It continues to go down, which means it goes to negative infinity, and it continues to go up, down and up. It's positive infinity. To verify whether it's a function or not, we can only draw one line and realize that this line intersects this more than once, makes it not a function. Any vertical line that would intersect it more than once makes it not a function. Another situation here. So we're looking for the domain first. Under X, this means it never stops on the left, but it starts here. X equals 8. X equals 8, but we're going to keep it open because it's not a closed circle. It's an open circle. So it goes from negative infinity left to 8 with a parenthesis because it did not close. And then the range is how far it's extended over the Y. It goes down forever, so that's negative infinity. It goes up, but stops for Y equals -3 with an open, so parentheses. This will always, no, all vertical lines will touch this only once, making this not a function, making this an actual function. I'm looking at this graph here. It goes indefinitely down and up, and the down and up keeps going left and right, because you see with this slope it continues like that. This one will continue like that, with the tendency to go left while going down and right going up. So left going out while going up and right while going down. So domain will be negative infinity to infinity, never stops going left. As it goes down, as it goes up, never stops going right as it goes down. So it's going to be negative infinity, infinity, this one, so, which is all real numbers for both of them. And we want to estimate G of 2. That means the Y value for X equals 2. X equals 2, the Y is -1. So G of 2 equals -1. Is it a function? It will pass the vertical line test, then yes, it's a function. Okay. Next, we want to use this to find f of x equals -6x plus 5. We want to calculate f of 0, f of -2, f of 0, f of -2, f of -1, f of 1, f of 0, f of 2. So let's start with f of -2. F of -2, meaning that x will replace -2 in the formula for f of x. So I just plug in -2 for x. So that's -6 times -2 plus 5 equals 12 plus 5 equals 17. F of -1, that's -6 times -1 plus 5 equals 6 plus 5 equals 11. That's -6 times 1 plus 5, -6. -6 plus 5 equals -1. -6 times 0 plus 5, that's 5. That's negative 6 times 2 plus 5 equals 12. Negative 12 plus 5 equals negative 7. All right, just substitute the value. This one is more complicated, but it's the same situation. So 6 times negative 2 squared minus 8 times negative 2 plus 8 equals 6 times 4 minus plus 16 plus 8. That equals 24 plus 16, 24 plus 24. So that's 48. F of negative 1 is 6 times, 6 times negative 1 minus 8 times negative 1 plus 8 equals that squared. That's 6 times 1, 6, plus 8 plus 1. That's 6 plus 9, 15. 6 plus 9, 15. F of 1 is 6 times 1 squared minus 8 times 1 plus 8 equals 6 times 1, 6, plus 8 minus 8, 0. Well, we can break it down if you want further, but that's pretty much what it is. So that is 6 times 1, 6 minus 8 plus 8. That is 6. That's 6 times 0 squared minus 8 times 0 plus 8. So that equals 6 times 0, 0, minus 8 times 0, another 0, plus 8. So that is 8. 6 times 2 squared minus 8 times 2 plus 8. That is 6 times 4 minus 16 plus 4. That is 24 minus 12. That is 12. Well, actually, this is not 1. This is 8. And the total would be 6 plus 16, that's 22. And then over here, this is not 4. This is 8. So that's 24 minus 8. Minus 8, which is 16. Okay. So that fixes the errors that I made. Here, for this question, we've done multiple problems of the same category, but over here they are asking me more questions on that. So domain is how far it goes from left to right. We know it goes from that's small, but that's negative 5. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. Okay, so negative 5 with a closed circle, negative 5, and it goes all the way to positive 1 with an open, so 1 with a parenthesis. Okay, And then the range would, how far it go from bottom up. The bottom value is +1, open. And the top value is 2, 3, 4, 5, 6, 7. 7, close. And we're looking for X and Y intercept. X and Y intercept. We obviously obviously don't have a X intercept because we didn't touch the X. You see, that's the X. We didn't touch it. So D and E for the x-intercept, and the y-intercept is the ordered pair where it touches the y-axis, which is 0, x equals 0, y equals 2. But in MATLAB, you might want to add it as just 2 because that's how it's set up. But on a test, you may want to give it as an ordered pair on your paper test. On your paper test, you may want to provide it as a ordered pair like this. And then we want to find f of 1, f of -1. F of -1 is when x equals -1, what is y? X equals -1 here. Let me go up, touch the graph. Y equals 1, 2, 3. And what is f of -2? When x equals -2, let me find y. When x equals -2, y is this. Let me count. The numbers are small. I'm going to just count this from here. So that's 1, 2, 3, 4. So that's 4. And then is it a function? It passes the VLT, vertical line test. So yes, it's a function. So next, the next number 23 is just remind you of the properties of exponent. If you have the same base, you know you need to add the exponents and keep one base. So x exponent 5 plus 7 gives you x exponent 12. This one, if you have a base with an exponent raised again to a second exponent, you multiply the exponent. So that's x to the power 5 times 7. That is x to the power 35. And this one requires more work. So you're going to apply the exponent property, exponent properties, and to get a more simplified expression. So we're going to work with the top first. So that equals this exponent multiplies all the exponents here. So that will be, and same thing over here. So we're going to have and the coefficient will also take the exponent. So if I have 2x exponent 5, 2x raised to the power 5 like this, that is 2 to the power 5 times x to the power 5. Whereas if I have 2x to the power 5, only x has the power 5. So the parentheses, they are very important when we have them in exponent properties. So that means here we have this. I erase this so we can see that n exponent 20, b exponent 16. So negative n to the 4th exponent 5 would mean -1 exponent 5 times n4 times 5. So exponent -1 exponent an odd number would be still -1. So if it was -1 exponent 4, for example, it would be 1. So -1 exponent n is 1 if n even, and -1 if n odd. Okay, so just making sure I review this. And now we have that's times negative n to the 20th power times b to the 20th power. Okay, down here we will have the same consideration. That's negative n to the 3rd, b to the 18th, and n to the 18th. Next up, since we have everything multiply on top and on the bottom, this negative sign can be canceled out. And then we can combine the exponents. 20, so that's n to the 40th. 1620, so that's b to the 36 over n3 n18, so that is n21 and b18. Now we can apply the rule that says if I have x over n over x, x to the n over x to the p power, it's x over n minus p. So we can apply it here. So that's n exponent 40 minus 21 times b exponent 36 minus 18. So then that is finally n 19 b 18. So the next problem here, number 25, is the same category. We're going to distribute that exponent here. It becomes the exponent of everything here. Distribute the exponent over everything. So that equals 5 to the 2nd to the 4th x, that's 36. We do 9 times 4 over, that's 4 exponent 2 exponent 4, because the exponent goes on top, goes to everything as long as it's multiplication, and y to the 16th times, over here we have 2 to the 2nd, y to the 5th, 5 to the 3rd, and x -6. Now we're going to simplify using the same property, that x exponent n over x exponent p equals x exponent n minus p. So let's start with the 5s. 5 to the 4th, 5 to the 3rd in denominator, so that becomes 5, 4 minus 3, right? The 2. Well, obviously, I think I'm going to keep my fractions because it looks like some of the results are going to need to be put in denominator. Because if they're negative, I'm going to keep them in denominator. So basically what I do is I keep the exponent the result wherever the largest exponent is. You see for exponent 4, you see for exponent 4 and 3, 4 is bigger, I keep it wherever the 4 was. And for 2, 4 and 2, the 4 in denominator, so the result, I'm going to write it in denominator. Hopefully you understand this. So that's 2 exponent 4 minus 2, so I can keep the result still positive. And let's look at the x's. X 36, x negative 6. Well, are we keeping the result? The result will be kept on top, and the 6 will be moved up. So that will be x 36 instead of minus 6 becomes plus 6, right? And then the last thing would be y. Y would go to the bottom because 16 is bigger than 5. So that becomes y 16 minus 5 because it was plus, goes moves to the bottom, becomes minus. And then now we can simplify. So that's just 5 x 42 over that's 2 squared, it's 4 y that's 11. The next problem, it's the same scenario. So we're just gonna distribute that exponent over to everything. So that equals 3 exponent negative. Well, instead of that, I will prefer showing you something that makes it go quicker. So if I have a over b exponent negative n, it's the same as b over a exponent n. You flip the fraction. So we're going to do that instead. So that would make life easier. So that is z squared p squared over 6z5 exponent 3. And then we can simplify because we have z2, z5, we would have z3 in denominator. So that is p squared over 6z third exponent 3. And now we can distribute after we simplify. So that is p6 over 6 to the third z9. 6 to the third would be what? That's 6 exponent 6. That's 6 exponent 3. That's 216 z9. It's 216 z9. It's 216. Okay, so that is P6 over 216 z to the 9th power. So next, it's the same thing that we did earlier in graphing equation. We can do this again. So more practice for this type of problem. So we have they say write it in slope intercept form. and then sketch the graph. We use the slope and the y-intercept to sketch a graph. So 2x plus 5y equals 5. I'm going to subtract 2x on both sides. That's 5y equals negative 2x plus 5. I would divide by 5. Y equals negative 2 over 5x plus 1. Your slope is negative 2 over 5, and y-intercept is 0, 1. So 1 down 2 over 5, and then we connect, and then we extend this on both sides, and that is the graph. Next is x equals negative 4. For this line, because there's no y, it's a vertical line. The slope of the line, this line is undefined. And then it's a vertical line, the slope is undefined. And then we can sketch this. It passes through negative 4. Through x equals negative. So that's it for number 28. For number 29, they give me this equation, this graph, and they want me to find the equation of the line. Well, you can see there is no connection. There's no intersection with the, it's a linear equation, but there's no intersection with the x. That means this line obviously is horizontal. Then because it's horizontal, you would see that it intersects the y-axis only at 4, so that's y equals 4. And then because the equation has no x, that is a line with a slope equals 0. So they wanted me to give the equation of the line, which is y equals 4. This one, they give me another situation where the line is vertical. So basically, it's going to be a line that's clearly vertical. Vertical line that intersects only the x. So that's the equation will be x equals 1 because it passes through 1. And then this equation obviously does not have y. It does not depend on any y value, which means the slope in this case will be undefined. Okay. Next, we're going to perform this operation with scientific numbers. So scientific notation, we multiply them. Basically, if we multiply two scientific numbers, a times 10 to the power p times b times 10 to the power n, we need to multiply a and b times 10 to the power n plus p. So a and b, so that is 7.9 times 1.1 times 10 exponent 48 plus 9. So, well, obviously we need to make sure that A and B here must be numbers. A, B are numbers that are not bigger than 10 and that are not smaller than 1. Okay. So we multiply 7.9 and 1.1. That is 8.69, which is corresponding to this condition, right? Because it's bigger than 1, bigger or equal to 1, and it's not greater than 10. So this is okay. Times 10 exponent 48 plus 9, 57. So that is the answer for this. So this one is the same situation, but this is dividing, and we're gonna make sure that when we divide the result, if it's not between, if the result is not less than 10 and greater or equal to 1, we manage to get it into correct format to be in scientific notation, and then we would find the standard form. So let's basically the same thing happens if we have A times 10 to the power P to the power, let me keep N, over B times 10 to the power P. It's going to be A divided by B times 10 to the power N minus P. So this will be 1.76 over 3.2 times 10 to the power 3 minus 7. Well, we don't want to keep it in the denominator because scientific notation, that's how you have to write it, whether the exponent, you are allowed to write a negative exponent for the scientific notation. So that said, we're going to perform this division. We're going to perform this division. We got 1.76 1.76 divided by 3.2, that is 0.55 times 10 exponent -4. Obviously, this number is smaller than 1. So we're gonna move this decimal over to the right, which will make it a bigger in value. So now to complete this, moving to the right would require subtracting 1 unit here to make sure that we did not, because moving the decimal to the right, it's like multiplying by 10. But if you multiply by 10, you need to divide by 10 to keep the number the same value. Divide by 10 means like if I have 0.55, that's a number that is less than 1. Now, if we move the decimal here, it's like we multiply 0.55 by 10 exponent 1. But if we multiply by 10 exponent 1, we should multiply by 10 exponent -1 too. That will make it the same number, because this would be 1. So this would be the same, but we move the decimal. And then this one would be this -1 that we have here. It's like 10 exponent -4 times 10 exponent -1. So that's how we get this value. Hopefully you get what I was trying to show you here. And then now that gives me the correct format of my decimal form of my scientific notation, which is 0.5, no, not 0. That's 5.5 times 10 exponent -5. And then if I want it to be in standard form, so remember you have, so that's the standard form, 5.5 times 10 exponent -5. Now 5.5 times 10 exponent -5 will be, we have to move the decimal 5 times to the left. So we already have this. We need to move it 5 times. So that would be the sixth number, 0.00005. So we move it once, 1, 2, 3, 4, 5, and then the decimal is here. So 0, 0, 0, 0. We got 1, 2, 3, 4 zeros, and then 5. So we need 4 zeros. 1, 2, 3, 4, 5. Perfect. So this is that's another 5. So that's gonna be the standard form of your result. So if you want to write it simpler, it's too big, 0.00005. So I forgot to put that another 5 here. So that's it. And next we are adding or subtracting the polynomials here. So basically what we do is that I'm going to bring those ones in the same order underneath of the like terms so we can calculate this. So for this one, I'm going to bring this one down here. So -7 y cubed plus 2y squared plus 10y plus 10. And I will bring this one too. So that's -7y cubed plus 3y squared plus 9y minus 7. So I would combine the like terms. These are combined together. So that is -14 plus 3, that's -11y cubed. Um, and then you have -10 plus 5, so that's -5y squared. So 3 plus 2, 5. 5 minus 10 is -5. And then 19 minus plus 1, that's 20 plus 20y. And then you have 10 minus 7 is 3. 3 minus 1 is 2 plus 2. So this equals -11y cubed minus 5y squared plus 20y plus 2. Next, for this one, we can FOIL. So we're going to rewrite it as 7y minus 4 times 7y minus 4, and then we FOIL. So that's 7y times 7y, that's 49y squared. 79 times negative 4, that's negative 28y. Negative 4 times 7y, another negative 28y. And then negative 4 times negative 4 is positive 16. Combine like terms, 49y squared minus 56y plus 16. Our next problem, same process. It's 7x plus y times 7x plus y. We do FOIL, that's 49x squared. That's 7xy, another 7xy, and that's plus y squared. So that's 49x squared plus 14xy plus y squared. The next one, you can do the same thing, or you can do the uh, box method. I'm gonna try the box method since we've already done the other method twice. So I'm gonna put x here and then 5 here. That is x squared plus 7x and then plus 4. I'm gonna change the color to perform the operations. So x times x squared is x cubed. X times 7x is 7x squared. X times 4 is 4x. 5 times x squared is 5x squared. 5 times 7x is 35x. And x times 4 is 5 times 4 is 20. So these two are going to be the first and the last terms. These ones will be combined together because they will be like. So your answer will be here. The first term, x squared, x cubed. And then these two combine, that's plus 12x squared. These two will combine also, plus 39x, and then plus 20. Okay. Next will be a division, but when you're dividing with one term, a polynomial divided by a monomial, you have to just break it down for each. So I'm going to separate this. That's 8x to the 6 over 2x3 minus 8x to the 4th over 3x3, and then plus 3x to the 3rd over 2x3. Simplify this. 8 divided by 2 is 4. X6 minus 3, that's x3. And we do the same thing for each term here. That's a 2 right here. That's a 2. So that's minus 4x1, and then plus x3 cancels out, 3 over 2. For this one, we will do the same thing as well. We would have 12b 4t squared over 2bt plus 2b3t over 2bt plus 10bt over 2bt. And then we would divide 12 and 2. That is 6. B4 minus 1, that's B3. T2 minus 1, that's just T. Next, plus plus 2 divided by 2, 2 cancels out. B2, T also cancels out. And then plus 5, B cancels out, and T cancels out. So that's this one. Last, well, the two last problems are synthetic division. Synthetic division is when you have a binomial in denominator. So you're dividing a polynomial by a binomial. When you have that, then you're going to set up the division. That's the setup for your division. So we want to solve this equals 0 to find x. Over here, we will solve denominator equals 0. When we solve it equals 0, we get x equals 4. So that's the value we put here. So we put this value here, what would be the divisor here. And then we would put all the coefficient here. That's a 1. That's a -1, -18. That is +4. We have all the coefficient, making sure that this is in order, descending order of exponent. If it's not, then you need to rearrange the terms so you have it in descending order of exponent. So now we start this with dropping the first coefficient, 1, multiply it by the divisor here, that's 1 times 4, bring it underneath of the next term. So, and then we can combine these two, that will be 3, and keep doing the same process. 3 times 4, 12, and -18 plus 12, that is 6, and the 6 you multiply it again by 4, that's 24. That's -6, so that's -24, and then that will be -20. -20 is your remainder. That's your remainder, and the solution would be given in the format of P over Q, P over D, the polynomial divided by the divisor, is P, that's a polynomial, D, divisor, equals the quotient, which is the result you're going to use with that. Given that x was a power 3, you divide it by a power 1. So you subtract these two exponents to get the power of the quotient. So 3 minus 1 is 2. So that's x to the second, coefficient 1, x, coefficient 3, and the 6 is your constant. Coefficient 1, and 6 is your constant. So your quotient will be Q equals x squared plus 3x minus 6. And you remember x squared, I told you how we found it, is when you subtract the exponents of d of p, and exponent of 1 would give of exponent of p here, which 3, minus exponent of d, that's 1, it would give you the 2 that you get here, the exponent of your q. And then once you finish with that, you're going to write your remainder plus remainder divided by the divisor. So if we follow this pattern, we have Q already and we have everything else. So we can write the answer for this synthetic division, that is P is x cubed minus x minus 18x minus 18x, x squared minus 18x plus 4 over x minus 4 is the quotient we found it, x squared plus 3x minus 6 minus, because the remainder was negative 20 over x minus 4. And then here, that's the last problem for the test review. We have the same scenario. Solve this equals 0, which gives you x equals negative 6. So we have negative 6, 1, 2, negative 24. Drop down the 1. That's negative 6, negative 4. That's positive 24. And that's 0. Remainder is 0. That means x plus 6 is a factor of x squared plus 2x minus 24. So in this case, you're going to write x squared minus 2x plus 2x minus 24 over x plus 6 equals, what's the quotient? Q equals, the exponent of the quotient will be the subtraction of 2 and 1, so that's 1, so that's just x, and then negative 4 would be the constant, n minus 4, x minus 4. So you're going to have x minus 4 plus whatever the remainder is. Remainder is 0, so 0 over x minus x plus 6. This is going to be 0, so your answer is x minus 4. So that's it for your review.